Hello and welcome to Technical Utkranti, and today we are going to start new section which is binary search. And in this video we'll be looking how to find nth root of a number using binary search. So let's have a look at the thought for the day. All right. So this is the new section binary search, and these many topics we have already seen, and this is the first video. So let's get started. But first of all, let's understand a little bit about binary search. We know linear search. In linear search, we have an array and want to search an element. So we compare this element with every element in the array. And in the worst case, the time complexity could go on to O of n, which means that in the array we find the element that we are searching at the end, which means that we have to do n comparisons. All right. What about binary search? In binary search, we need a sorted array, and by every by every search we reduce the search space by half. So if it was array was 8 elements long, then by one comparison we'll reduce the search space to 4. Then by another comparison we'll reduce the search space to 2, and so on. Because this is possible because the array is sorted, right? But is binary search just limited to finding an element in the sorted array? No. And that's why we'll illustrate this concept by finding nth root of a number. But first of all, let's have a look on binary search. So let's suppose we have this array over here where the elements are sorted. How are we going to apply binary search on it? Okay, we basically want to search this element and return the index of this element in the array. So we have low, high, and until low is less than equal to high, we calculate mid. At mid index, we see if we have found if we have found the element, we return the index. Otherwise, if the element at the mid index is greater than the search element, then a search element lies over here, right? And if it is less than the search element, then it means that search element lies in this half. Accordingly, we need to change the low or high pointer to modify the search space. So earlier low is here and high is here, and between low and high is the search space. Now, if the mid element, as according to our case, is smaller than the search element, right? So what we do is that we make the low pointer go ahead of mid pointer. So low pointer, earlier there was 0, 4 and mid came out to be 2. Now low is 3 and high is 4. Low is still less than equal to h, and the mid comes out to be 3. When we see the value at index 3, it is equal to the search element and we return the index. So as you see, just in 2 steps we were able to do or able to find the element that we were searching, right? The only prerequisite is that the array should have been sorted. So that is binary search. Now let's go back and look at the question. Okay, we need to find nth root of number m, right? We need to find nth root of number m. So for any number m, any root would be between 1 to m, correct? So our search space is between 1 and m. So low becomes 1 and high becomes m. Alright. After finding low and high value, we calculate the mid value repeatedly. And this mid value should should repeatedly go towards the nth root. How it will go? What we'll do is, we will take mid and multiply itself n times. Alright. And store it in the answer. Correct? If mid is the nth root of m, then multiplying mid n times to itself should produce m. Correct? So that is what we are expecting. We compare this answer with m. If answer is greater than m, it means we need to reduce the mid value, right? And if answer is smaller than m, it means that we should increase the mid value. So how are we going to increase or decrease the mid value? So if we make high value smaller, then mid value will become even smaller, right? And if we make the low value bigger, then mid value will also become bigger. So accordingly, we change high or low value, and then mid is calculated again. All right. Now, till when will we continue with this while loop? We'll subtract answer with the number. And if it is between plus minus epsilon, epsilon is a very small value, this thing. So if this difference, the difference of number and the nth multiplication of this mid value or mid value to the power of n minus this number, if it is between plus minus epsilon, which means it is very close to number m, then we can say that mid is the nth root of m, and we return the value mid. I hope you understood the explanation. Let's submit it and see what happens. Yes, our answer is accepted. So I hope you understood the explanation of binary search and its application in finding the nth root of a number m. If you did, please give it a like and subscribe to my channel. Thank you. Bye bye.